Welcome, this is where nerds come to learn things. If it's your first time here, click on the subscribe button and on the bell icon to get notifications about new videos. Thanks for watching, hope you enjoy it. So right here is the Fluke 540B thermal transfer standard. I put this up a little while ago. I haven't really used it yet. I've opened up a little poke around. I did a little bit of video on it before when I first got it. And the Mercury battery is inside it, which is normally sits at 1.35 volts, as while I use a Mercury battery. You can't get those anymore because they're unsafe, and as a result there's no battery in it, and it's all corroded anyway. It has a battery pack which looks like it's actually okay because it still works, but I need to modify this to add a power supply to run at 1.35 volts to replace the battery, rather than having a battery backup in there. I could use a little battery pack and then run that easy enough. That's certainly possible. But I was thinking about just using a voltage regulator. So I've got a little circuit here which I've thrown together. It's not even soldered up yet. I'm not sure I'm going to use it. But this, in theory, based on the resistor values, should be 1.35 volts, or give or take a few millivolts. So the tricky thing is, this has got multiple ground circuits in it. So it's got a chassis ground, it's got another ground in there, and it's got, which is used for the main battery packs and reference, like main reference, common rail I suppose. And the reference has also got its own ground as well, which only goes to the galvanometer. And the thermocouple setup, so it only goes to that. So it's actually isolated normally. That 1.35 volt battery is isolated from anything else, which makes it tricky, because if I want to run a little regulator in there off the battery pack that's in here in order to generate that 1.35 volts, I have to tie those two negative rails together. I'm not sure that's going to have some kind of side effect. I've done a little bit of testing, injecting with my power supply to replace the battery, and it seemed to be okay, but there's no guarantees it's going to be alright. So yeah, I'm not quite sure how the procedure works. I stick a battery pack in there and just do a little, and use this anyway, but have maybe a 9 volt battery or something like that in there instead, or something like that. So it's still isolated, and you just, I don't know, figure out something. But yeah, because the Mercury battery is normally here supposed to last for about 2,000 hours or something, I reckon. And the reason I use the Mercury battery is because it's got a very stable voltage. It sits at 1.35 volts basically its entire life until it's dead. Right, a very stable voltage output, which is why it's used as a reference voltage. So obviously I need to do something to replace that, and trying to figure out the best way of doing that is a little bit tricky. On the EV blog forum there's a post from 2013 or some which actually done that modification, and there's also it looks like later on Fluke actually had their own module in here as well, because there was a Fluke branded voltage supply, voltage regulator in here in later versions. So it may be perfectly safe to link those grounds together, because I don't see any other way of doing it. I don't know. I'm going to have to try and investigate that some more, because I don't really want to link those 0 volt rails together unless I actually have to, because it's not designed that way. You think if it didn't matter we would have grounded them together anyway, but they're not. They're intentionally isolated from each other, so that makes me wonder about if it's going to affect the readings it does and that sort of stuff. Now the reason I'm working on this now is because I'm working on the Valhalla and I need to calibrate it, and which is the reason I purchased this was actually calibrate my Fluke 5200A, and to also do the Valhalla as well. I think I purchased this before the Valhalla actually, but I mainly purchased this for the Fluke, the 5200A AC calibrator. So I've already got a DC calibrator, which is one of the things you need for this comparison thing. So you can do a comparative measurement, and that way I can calibrate the AC calibrator, which is why I bought this. And it does seem to do something. It clicks when you put it into the on positions, which is a good sign from what I've been reading. It means the protection circuitry works, which is quite important apparently. Whether or not the rest of it works, I don't know yet. I haven't got that far. So the first thing I need to do is get its reference supply sorted out, and then I actually need to try and use the thing and see if it actually goes or not. Right, so right here is the plug-in from the Fluke 540B. Now what I've noticed, I've been playing around with this, trying to just figure out how it works and use it and see what issues it has. I've still got started the power supply section yet, where 1.35 volts needs regulated supply, which this is for. Once I build it, I'm going to use batteries to keep it isolated. I was going to use a tap off the internal power supply, but I thought, nah, best keep it isolated. That's what it's designed. Anyway, I've noticed from playing around with it, these switches here seem dirty, especially this one. So I'm going to pull this thing apart, and it's got this cover over here, which obviously keeps the dirt out. So I'm guessing what I need to do is remove these screws here from the back and lift this plate off. At least that's the way it appears. So we'll have a look and see if that's actually how it works or not. Let's see what's going to go in there. So this, I've got to take these two little nuts off here. I'll just use this for now. I hope that's what they're for. Shaft's not turning, so probably right. So I think shaft's turning. I'm hoping that's just holding the cover on. I'm really hoping that's the case. Here we go. Let's rescue these so they don't drop any bits anywhere. So yeah, just a polystyrene cover. And there's the inside. So, what do we have in here? Oh, there's a relay there which you hear clicking when it's operating. Some adjustments, spark gap. Also the switches. This is my main one here I want to clean up. It's all solid conductors, so they're wires, which is interesting. Obviously I want to keep it all fixed. It's custom resistor. Other resistors around there, obviously it's all for the ranges. With the voltage input selections. So I've got to clean all these switches in here, all these wafers. A wafer there, obviously there's wafers at the back. A few of those. So I'm just going to spray it with some of my contact cleaner stuff here. So on last time posted a link to a deoxit can. Right, deoxit is like an American thing, and I can't get deoxit in this country. I don't believe so. I've never seen it. I've never seen it for sale ever. So you know, although deoxit is like this seems to be the go-to thing, it seems to be a bit hard to get here. So I might try buying some, but being aerosol cans, it may not ship. There may be issues with sending aerosols, I don't know. But anyway, so we've got the bottom here. A few little diodes and some caps and stuff in there. Soldering all looks wonderful. I can't see any issues with soldering, as you would expect from something like this quality. So, alright, all looks fair enough. So let's clean these switches up a bit. So I'm just going to use this stuff. It should be safe in phenolics. These, because if you use oil or anything like that on these, they absorb it and they end up breaking. So you have to be a bit careful what you use. Alright, so let's just give it a spray. Going to be a bit thorough with it. There's quite a few years worth of gunge that's on here. Although, not going to be gunge, but it'd be just be oxidisation. Because even if it's shielded, you're going to get that. When this switch wasn't too bad, it just had a little bit of touchiness to it. So I'm not overly worried by this one. We'll call that one done. Let's do the next one. This one was quite bad. This one was playing up the most, especially on the DC side. It's actually feeling a lot better as well. It's actually moving a bit easier now. Lubrication's getting in there. So, get this drag on it. Can't see any dirt in there really. Anyway, so hopefully that's all it needs. I'll have a little look around just to make sure things look okay as well. Because what was happening is the protection circuitry was kicking in all the time, or something was kicking in. And what I found is when I was trying to use it, I have to go to like a really high voltage, go to search, which I then bring up on the meter, really low, and then go to transfer, and hopefully it doesn't kick in. Sometimes I realise it can still kick in, it would just peak in the needle. And if it didn't kick in and it was sitting really low still, I could just bring the voltage down until it is, you know, the relevant voltage range. So that then seemed to behave a lot better. But I don't know if it's just because of the switch playing up or whether there's some other issue going on, I don't know yet. I thought I'll give the switches a clean first, that eliminates that at least. And there may be some leakage in a capacitor or something which is causing it to trip. I think it's like a protection circuitry or something going on. So it may be something, you know, a out of value resistor or something. You know, these old carbon resistors, those things can go off value. So I might have a little poke around, see if I can see anything obvious, but there probably isn't really anything. It's probably just a switch. So I thought I'd zoom in on this in case you can actually see it. Now on the back of this switch here, can you see that grime there? Bit of grime just there. So there is some debris in here. That. You can see it with my finger. If I can get the focus at the same time, it'd be nice, but there's a couple of bits there. So there is a little bit of dirt in there, which obviously this cleaner is going to be helping with. So I might give this switch a bit more of going over. Alright, so I've got it back together. Next thing I'm going to do, I think, is just give these contacts here a bit of a clean. They probably need a little bit of a spruce up. So what I use for that is just a little fiberglass pen. It's quite, it's a little slightly abrasive, but it's not overly so. It's not as bad as like scratching it with a screwdriver or something like that. So it's a little bit more gentle on it. So let's put a bit of some lube on it as well. And let's give it a little scratch up, just very gentle, just a little bit on each one. These are probably gold-plated contacts as well, so I don't want to do too much on them. But it just takes a little bit of tarnishing off. I found that's worked quite well in the past for doing various things. Right, I'll do the other side as well. And I'll try and get inside the cabinet and do the actual socket this plugs into as well. I won't do that on camera though. But you don't do too much on this, otherwise you end up rubbing away any gold plating. You just want to take off any surface tarnish. So I'll put some of this on it as well, just to help it slightly, hopefully. Okay, so there's the actual plug-in section where the module plugs into it, and there's the actual socket. So I can't really get in there very well. I'm getting maybe a little bit. Let's try and rub it in slightly, but I don't think I'm going to get very far with this. I can only try and help slightly with it. It may or may not help. I mean, there's no harm in trying, is there? But it does look like it's all gold plated anyway, so. Right, so let's do that. Spray a bit of this on there just to help it slightly. Then I'll put it back together. So, the module drops in there like so. And stick it up. That's it. That's it. Now, so I'm currently giving you readings because I don't have the reference battery sorted out, so there's no battery there, but the other battery is there, and that's what seems to be working. So it is actually doing something there. I might have to inject a voltage to it, but yeah, what's happened before was I turn it off for now. You have to be on to demonstrate this. So if I had, say, a 1 volt level going into the DC jack here, I'd do search, and even if I set at 1 volt, it'd peg out the needle. Right? I set at 2 volts, it'd peg out the needle. Right? It would actually peg out and stay there. It wouldn't come back down again. I'd have to be sort of around sort of 100 volts or so. Bring it over, bring it into search. The needle would be really low, you know, wherever it is, you know, barely moving. Then I can bring the voltage down to the range I'm actually trying to use, and then it'll seem to be okay. But then when I've got a transfer, it could do it again. So I also found out to do the same thing with going to 0, bring the voltage right up, go to transfer, and then bring it down to the correct range, and then use the galvanometer thing. Alright, so I'm hoping it's just dirty switches, because it did seem to be erratic. It didn't seem to be a consistent thing. Sometimes I've got to go down, it'll be alright. Other times I've got to go up and back down again, it'll trip out. So I need to actually investigate that some more. So well, I'll start giving it a clean, and we'll see if that changed anything or not. I did a quick poke around with those resistors that are in there. They all seem to be pretty close to the right value. Not 100%, but they're pretty close. So it's probably just, you know, the circuitry around them which is affecting the readings. Nothing obviously bad, at least. So it's all looking alright so far. Alright, so this is the Fluke calibrator thingy, film transfer standard. I'm going to need to get this out and sort out the D-cell Mercury battery issue. And this is the circuit I want to put in. It's a little lithium, and a little voltage regulator here which I built, which is a little LM317 running at 1.35 volts. I've already adjusted the resistor values and stuff like that, so it should be 1.35 volts exactly. At least it was when I checked it yesterday. So I'll open this thing up and we'll look at how I'm going to actually do this conversion. And there's the insides. There we go. And there's the battery packs. All in the back there, behind that metal plate is battery packs. Transformer, charging circuitry here. And this is the distribution for the power from the battery packs. There's the D-cell holder right there, where the Mercury battery normally sits. And when I got it, there's a battery in there, which had been leaking. And it's corroded off the bottom terminal, just here. I'm going to leave all that intact. I'll need to obviously protect it so it doesn't short out or anything, but I'm not going to be using that section. I'm going to be obviously somehow fitting this in. I'm not quite sure exactly how yet. I may have to, don't know if I can strap it onto the back of there, there's enough clearance. I'm not quite sure yet. I'll have to figure that out. But that's where the wiring comes out for the power, and it all comes over through this cable here to the front panel here. And the switch I need to work on is this one right here. So I need to do some changes on the back of this. I've already figured out what I need to do. Bit of preparation, and I want to make sure I'm actually not doing it wrong. So this is my rudimentary drawing of the back there. And these two switch terminals here are the battery check function. And that terminal there is the on function, so I need to actually change the outputs onto those. I don't mind if I have to charge up every once in a while, you know. It's not something I'm going to use very often anyway. What worries me most here is the NiCads in the back there, because they have quite a bad self-discharge rate. Now I'd fully charged this previously. This has been sitting on the shelf there for about 1.5 months, I think, and they're already very flat. Only about probably 20% or something before we charged them again. So the shelf life on those batteries isn't very good. So it's actually very tempting as well to do some kind of conversion of those lithium to lithium as well. Maybe put some power packs in there, you know, something like that. But anyway, that's another project. I just want to get the thing working. Right now it's a workable state if I just do this modification. So yeah, so it's got a little micro USB on there. I was actually thinking I could maybe put a hole in the back casing and mount it that way somehow, so I can just plug a cable into the back, but I don't know if that's going to be physically possible or not. there just isn't really the room for it. I think it just won't fit because you've got the other battery pack behind there, which is kind of in the way. So I don't think that's actually going to be feasible, which is a bit of a shame. Also, the other problem I've got is that this circuit board's got no mountings on it. There's no mounting holes, there's no standoffs. So that in itself is a bit of a pain too. Now, if I take the battery out, the actual holder's got some holes in it, but there's a track running, I can see a track running right down the middle of the board behind those holes. So if I drill through those holes, I'll be drilling through that track, which is just lunacy. But anyway, they could have designed that a bit better. So in a way, I was actually tempted to take this holder off and actually drill holes through this board and make it mountable. I may still have to do that yet, but we'll get the electrical side of things sorted out first. I've got a few of these. If I ruin it, I suppose I can always get another one, but I'd rather not ruin it. So basically on the switch here, so there's that wire link I had in the my rough drawing there. So that terminal there is one of the test positions. So it's a dual 4-way switch, right? So there's one side, there's the other side, individual poles. And so when you turn the test position, the battery connection, let's just get something to point with. So, right, there's the battery wire right there, that white and grey. That's from the battery holder directly to here. That goes onto that common terminal right there. I don't know if we can see this on live stream. And then in the first test position, it comes to this terminal here, which goes from there straight to the board here, which has got a little voltage reducing resistor and a trimmer to allow for adjustment to the scale. And then the other side of the link goes over to here, which goes to one end of the resistor, which goes down to another switch wafer, which is then switched to the negative side of the battery. Alright, so it's actually switched on and off to the battery side. The yellow wire, those yellow wires here are the battery negative. Okay. So the resistor's always on there, but it's also got switching to that to switch that in and out of circuit as well. But the resistor's always connected. So all I've actually got to do in order to make this work, I need to keep the load resistor on there in order to keep the load on the battery. So it's actually more so it takes the service charge off the battery a little bit. So you need to keep that there. So I need to take from this switch wafer, I need to basically disconnect both these two wires from it and put a resistor in series, which will then lower the voltage going for the test circuitry. And then on the output, which is that one there, I think it is. 1, 2, 3, 4. Yeah, that one there. That's the on position. That is the one I've got to put the voltage regulator circuitry in series with. Okay, so that's the white and red. That's the actual power on, which is the circuitry for that battery. Alright, so it's actually a fairly simple modification. It just requires a few slight changes and obviously building a regulator circuit and stuff to suit. And I think the hardest bit is actually mounting that battery in there and getting that physically suitable. I mean, really my instinct is to try and find someone to put the battery first. So I need to try and get that figured out. I mean, I want to mount it on that panel in the back there, so when I take that panel out, I can get to this battery and charge it. Part of what I need to do is keep this thing completely isolated from the chassis. Now, the first thought I had when that battery issue came to light was that I could just chuck a voltage regulator in, like I could just put this in, wire that into the circuitry, running off one of the other battery packs, and done. Right? Don't have to worry about having another battery in there. Well, I was looking into the circuit diagrams for that, and it's a completely isolated battery circuit. And I think, well, they must have done it that way for a reason. That battery just goes to one thing, and that is it. There's no other ground references which are shared, nothing like that. It's completely isolated. I think, well, there's probably a reason for that, so I'm going to keep it isolated as well. What I do is hook this up into this section here, put a resistor in series with those two wires, pull those off that switch, put those resistors in series, hook this up to the negative side, which is those yellow wire down there, positive side, which is the input voltage to the switch, and this little wire jumper here which is coming off to that existing wire. Okay, so that is basically it. Obviously apart from changing the supply, alright, which I'll then do at the other end when I take that back panel out instead. Okay, just to try and work on it that way. It'd probably be easier that way. Right, this is the circuit diagram for the Fluke. Now, well, one of the diagrams is actually another one there as well, which is for the actual plug-in unit, which I've cleaned up the switches on. So this is the diagram we were interested in right here. So this section here is the power supply, main battery inputs. So you can see the regulators here, and it's got batteries here and here as well, which go through the switches. So that's basically this section here is the power supply, and that's what we're really interested in. So let's zoom in a bit. Now this is that main power switch here, and here, right, S101 is the power switch. So that's got 6 sections. So see, it's got a bit going on. This is the main NiCad battery pack section just here, right, which is also depicted like this as well. It's got 2 separate battery pack sections for the NiCads, and this one here is the Mercury battery just here, right, which is one that we're actually working on right now. Okay, so this depicts each cell. There's the Mercury battery, 1.35 volts, which is between terminal 5 and 7 of that distribution connection. Right, you can see over here 5 and 7. There's a switch contact. So what we're interrupting here is we're messing around with the reference battery checks. We're adjusting that voltage reference so that the system can still check the battery voltage, and also inserting that regulator on the inside the on section. Right. So it will accept that 4.2 volts wherever the battery's sitting at, and convert that down to 1.35 volts using that regulator. Okay, so inserting the regulator inside the on section just here, and we're modifying this by adding a resistor in series. That's pretty much what we're doing. Okay, if I come up to the top here, just here shows the other switch sections and the metering. Okay, so when you're doing the reference battery check, so when you're in that position, it ties that to ground there on the negative of the meter, and the positive meter is then tied to that plus V3 reference battery check, which is the same terminal as down the bottom here. Okay, there. Okay, it goes to that. So it sort of loops back into itself, and there's that adjustment and stuff there, which I may or may not need to tweak. We'll see how we go with putting fixed resistance values in first. Alright, so let's take these wires off here, and then I'll actually show you what I was doing. I had a test set up. I should do that first actually. I have a test set up here, so I've worked out what resistor value I need, roughly. So I should actually do that first. So let's hook that up, and I'll show you that. Right. Just to go through that part, I've already done some research on this and figured things out before I started recording, obviously. Try and be prepared. So I've got the negative, which goes onto terminal 7, which is that one there. And the positive, ignore the wire colour, it's wrong. Actually I'll swap those around, shouldn't I? Make more sense. Positive goes in terminal 5, which is that one there. Okay, make sure I'm not shorting anything out. It's all good. So I'll turn my power supply on. Now this is based purely on the battery test function. Okay, so that's what I'm working on right now, is battery test. Can you all see that? Yep. So if we go to the battery test function there, reference, turn the supply on, that's set at 4.2 volts, which is the most the battery should be. And that's what I'm getting on there. That's at 1.5k. Right, if I go to 1k, it's actually close to where I want it. So a 1k is kind of what I want. Okay, but if I change the power supply voltage down by, so if I go down to say 3.7 volts, it's dropped slightly. 3.3, 3.2. I'm not quite sure what lithium cell is going to drop out here. That's 3 volts. So it's still below the marking there for the battery. So the batteries are that first band just there. Alright, it's a very small section at the top there where it says overload as well. In that section is where the battery OK voltage is. So that's at 3 volts there. And that's at the 4.2, which is like the most the battery will be at when it's fully charged. If I do 1.5k instead, right, so that's 1.5k, so sitting right at the bottom end of that really, at 4.2 volts. And if I drop it down, say 3.5, you know, so go 3 volts there, so it's slightly lower, not a huge amount. So I'm going to base it on the high level 4.2 volt battery when it's fully charged, and the 1k resistor. Right, so 1k is up there, which is like the most it should be. So that's what I'm going to base it on. So if I stick a 1k resistor in series of those wires, that should give me the correct reading for checking the battery voltage to make sure it's charged up okay. June the 4th, 1985. Okay, 1985 is when this thing was made. So 33 years old. Not bad, is it? And it still works. Chuck a 1.2k in there. That should be in between the two, which I think will probably be alright. I suppose I could try it out, shove it in series and see what he thinks of it. Let's try that one again. So yeah, that's in the middle of the range. That looks good. So let's just drop it down. So the threshold there for that bottom of the range is about 3.6, 3.7 volts bottom of that range. I mean, it's going to be an easy resistor to access anyway, so if I do need to change it, I can just do it again later on. It'd be pretty easy to do. So this is a piece of gear I don't use very often. It might even be a case of I'll use it and then take the battery out. It might be that because it's only for calibrating my AC calibrators, and that's the reason I got it, and to do videos on its repair and restoration sort of thing, you know. So yeah, it's not going to get a huge amount of use, but I still want it to be usable, and that's the thing, you know. I like to have things, if I don't use it often, and I've got lots of bits of gear here which I almost never use, but when you want to use it, you want it to work. So I need to take this wire here off and that orange wire there. Something I should point out, there's an orange wire over here. I noticed this yesterday. Right there. There's an orange wire. It's not soldered onto the switch, it's just floating around. It's hooked over, but they forgot to solder it. So this has been sitting like this for 33 years. Who knows, maybe someone thought it was faulty because it didn't work. And maybe that's why it didn't work, because the switch wire there was not actually attached, and when in shipping maybe it started making contact again. Who knows, maybe that's why I got it cheap. But yeah. So that wire there is not actually soldered on, so I need to sort that out too. That's pretty hilarious. Yeah, for old test gear, it's like, I don't know, it's kind of collectible in a way. You know, I've got so many bits of gear now, things I've purchased for doing videos. I mean, I only buy them to do the videos usually. This thing here is a little different because I actually want to add a function for it to repair the other bits of gear. But that's what I find I end up using, is I get a bit of gear and I end up using that to repair other bits of gear, which is, you know, quite helpful. So let's just fix this solder joint issue here, where there isn't one. Now, being it's been sitting there for 30 years, it probably needs a bit of flux. Here we go. 33 years later, it finally got soldered. Alright, so let's just figure out how I'm going to do this. I don't think I can put it across the back because of this transformer here being in the way. I'm thinking I might have to change this wire. Well, I should be able to lay it on there if I did that. Could put it that way like that. Think that would be okay? Yeah, that'll be okay. That'll work. Just do it that way. I'll stick with heat shrink over it. It'll be fine. Use tweezers, just a bit easier sometimes. And if I run the wires up that way, is that it? Is that a bit small? Just does it. I'll do that. Yeah, it'll do. Alright, it's going to get noisy. Yeah, hopefully I can make this reach. And if things shut up, I can try and talk over it. Can I get both wires through there? There's probably a better way of doing this, but you know, this is the way I'm doing it. Because, you know, I like that. Okay. So I need to solder those onto there. So I say this is the easy bit. Not the prettiest thing. Okay, well it's on. Just trying to get the heat shrink over it now. Right. Okay, is that part done? Right, let's get this wire here off and insert the voltage regulator circuitry. I need to think about where I'm going to mount this. I don't think it's going to get hot, so I'm not too worried about the heat sinking it. I probably will have to put like heat shrink or something over that to isolate it. I left this space here next to it in case I need to make mountings. I mean, if I need to, I can always double side tape it down to the front there like that. We'll run that round to there. So that can go to the switch. And that one there's got to go down to the 0 volt rail there, which is that yellow wire. So I can shorten this right down, I don't need that much wire in there. Get rid of that. Solder this negative on. Still plenty of wire, which is fine. I don't like to set things up too short, because if you need to move things or pull things apart, I don't like to have wirings exactly the right length, because you never know if you need to adjust it or dismount something and move things around. You just never quite know. So I always like to leave a little bit extra wire. It's less tidy that way, but it's more future proofed. Okay, is that side on there? Let's untangle this wire. do on the bottom of the ball rod, trying to go through it just a lot easier. Okay, so that's that side wired up. So in theory, if I stuck 4.2 volts on that supply, that should work. As long as this doesn't touch anything, it shouldn't. Just to protect it in case it touches something. Okay. So I've hooked up my power supply to the internal connections where the battery is supposed to go, and we'll give it a try. Power's not on yet. I'll start at 1.5, that should be fairly safe. So I'll turn it on. Yep, that's looking good there. Yep. So that's 3 volts there, which is seen as 120, which is about as low as I'm going to go with that battery. And there you go, 4.2 volts is up there, so it's just over halfway up the scale. So I think that's fine, at least at that part. So now I'll do the same check again for the on state and check the voltage going through here to make sure it's all good. So the voltage regulator's got about a 1 volt threshold before it cuts out. It's officially at 1.5 volts, but I was actually getting about 0.9 is when it actually started working. So if I check on the output there, nothing, turn it on, that's 2.5 volts, which is close to the dropout voltage. Try and get this on there, 0.25, bring it up, 1.35 or 1.35 is what I'm going for. Yeah, 1.347. Yeah, 2.7 volts is dropout voltage. So 1.4 above. So 3 volts lowest range is 1.35. So that's all tying in quite nicely, actually. So it's all working quite nice. If we go up to 4 volts, or 4.2 volts, which is the battery voltage, there you go, still 1.347. So all good, that will work. So I'll just check the milliamps on this thing to actually see how much current it's drawing in the on state, and it's only drawing about 2 milliamps or so according to my power supply. So I don't need to heat shrink the transistor, so that's all fine. So I'll probably just leave it in the heat shrink and mount it down here somewhere. So I want to stick that down with something. I've only got double-sided tape, not double-sided foam tape, and the foam tape works a lot better. I don't really trust this other double-sided stuff, it's not great. The foam tape certainly works a bit better. I've got some somewhere, there might be in the garage. Right, so we peel the backing off. This one, next challenge. So it's not as good as foam, but it might do the job. We'll see, I'll be surprised if it stays there. But it shouldn't matter if it does fall off, because I mean, it's all heat shrunk in there anyway, so it's not going to cause any problems if it does fall off. Let's put this back together. Okay. Actually, it's occurred to me, I didn't have that module plugged in, so because this wasn't in there, maybe it will draw more current once I actually do that. I should retest that, shouldn't I? Okay, So there's the battery pack out. Let's put this module back in again and retest the current in case I've got that wrong. Okay, let's hook this up again. Like to be sure of things. I don't want to take chances with things being different to what I expected. Okay, power is on. Let's turn the switcher out. All the way on. Yeah, still only a couple of milliamps, so that's fine. That's okay. Happy with that. Because it doesn't actually do a lot of that battery. It's just the reference voltage really, so it's not surprising it's really low current. So let's look at how I'm going to mount this in here now. Alright, so obviously that's the original battery terminals there, and you can see this one here has come off completely. But there's not a lot of room here. So it's a shame this is a bit too long. If I didn't have the circuit board on it would actually fit a lot better. So now I'm really thinking about using this particular board. All I need is a battery voltage, right? I don't actually need the charge board. I could mount the charge board somewhere else without the battery on it. That could be a plan. I want to try and keep this sort of thing intact though. I mean, this is the original battery holder. There's a bit of space on this side of the transformer. So I could actually fit a battery there. Could stick it side on. That way the terminal's on the side like that. So I'm starting to think I might need to dismantle this battery holder. That's where I'm leaning right now, because it will fit better without that USB charging adapter on it. I could just put a battery pack in and put this board somewhere else, or maybe dismantle the board and cut off all the unnecessary stuff, because obviously that charge circuit on the end is the important bit. I think that's the way to go. Let's get this off here. Good, positive negatives marked. That's always handy. And I'll mount that on the side of there. And I'll just dismantle it. Let's see how hard it is to get this thing apart. It's pretty easy so far. Very interesting. So that trace that goes all the way up here is a negative trace, but the whole thing is negative. That's weird. It's got all this grounding, but it's not using it as a path. That's strange. A tiny little track. Right. So now that should fit on there like that, and I'm going to run some wires to it. I'm not happy about the fact that it overhangs the edge slightly though. I suppose I could trim it off a little bit, couldn't I? Positive is that way. Yeah, it sticks out more than the battery, so I could I'll just trim that off very slightly so it's not overhanging. So if I've got that stuck on there with a bit of tape or something, then it might catch and pull the thing off as I'm taking it out the back. So I shall trim that slightly. Probably just on one edge is what it's going to need, just to give it a lead in like that, so it's not actually got a hard edge to catch on. That should work. And it'll make it stick to this. Hot glue I don't trust, not on aluminium. Okay, so some wire I'm going to use to hook up the battery pack to the original terminals. It's a bit thick, but it will do the job. So it should all be nice and simple. Now it's the negative terminal at end, which I have to bring to here. So I'll just go straight across there. I'll tuck it in the inside edge here, like that. I'll leave a little bit of slack on it too. Come on, solder. I think I might need to clean my tip up a little bit. Right. Kind of working backwards here, it's a bit awkward. Okay, so on. Now here we go, straight to that post, or I can go to that little through hole there, which has actually got the wire coming from the other side. I think I'll rather go to the post. Come on, here we go. Now is it a hollow post? Yes it is. Brilliant. So that's that wire on. Now we'll put a bit of heat shrink on this in case it falls off. Okay. Anything I can do to reduce the chance of a short is good. Right. Let's go to that tunnel there. Okay. There's that one. Right, let's cable tie these up. Find some small cable ties, I've got some here somewhere. They're too big, they're too big. Here we go. I like to try and do tidy work, but I'm afraid I'm not generally that tidy. I try and do it, but I've seen guys do much tidier work than me. Good enough for it? I think so. I think that'll be okay. Get that to stick in that double-sided tape there, hold it down. That'd be good. Cool. Let's drop the battery in. I suppose I should actually test it, shouldn't I, to prove it works. I'm so confident I'm going to put the screws back in. And this will be the time it doesn't work. That's how it works, isn't it? When you're sure it's going to be okay is the time it isn't. So yeah, I'll add that charge port on later on once I've got a 3D printed thing made up to go in here to make that all nice. Definitely a way to do it. I mean, surely out of the box is convenient, but it's like, it's not the best way. Right. Battery test. There we go. Yeah, battery test. On, well, I haven't got anything going right now, so you probably won't see anything, but there you go. See some activity there, Sam, when I flicked around. Yeah, you won't see much unless I've got an input signal going on. But so each battery checks out, all about the same levels, so it all corresponds nicely. I'm happy with that. It's good.